Here we have IIT Mathematics 2004 mains paper questions and solutions. The first question is, find the center and radius of the circle formed by all the points represented by z equal to x plus iy satisfying the relation modulus of z minus alpha by modulus of z minus beta equal to k not equal to 1, where alpha and beta are constant complex numbers given by alpha equal to alpha 1 plus I alpha 2 and beta equal to beta 1 plus I beta 2. Here listen, the circle satisfies this condition. So now what we are going to do is, we are going to take this condition first. So modulus of z minus alpha divided by modulus of z minus beta equal to k. Now if we square both sides of this equation, then we will get modulus of z minus alpha square divided by modulus of z minus beta square is equal to k square. Now this implies what? This implies modulus of z minus alpha square will be equal to k square into modulus of z minus beta square. Now this implies, now modulus of z minus alpha square will be equal to what? Z minus alpha into z bar minus alpha bar. So we get z minus alpha into z bar minus alpha bar is equal to k square into, similarly this term modulus of z minus beta square will be equal to z minus beta into z bar minus beta bar. Now we are going to simplify this equation. So now if we multiply these two terms, we will get z into z bar minus alpha into z bar minus alpha bar into z plus alpha into alpha bar. Now this is equal to k square into, now if we multiply these two terms, then we will get z into z bar minus beta into z bar minus beta bar into z plus beta into beta bar. Now this implies what? Now we are going to bring the right hand side to the left hand side, then we will get z bar minus alpha into z bar minus alpha bar z plus alpha into alpha bar minus k square into z bar plus k square into beta into z bar plus k square beta bar z minus k square into beta bar is equal to 0. Now we know that this term as well as this term consists of the factors z into z bar. So if we take out z into z bar as the common factor, then in this term we will be having 1 as the remainder, and in this term we will be having minus k square as the remainder. Now this term as well as this term consists of the common factor z bar. So if we take out minus z bar as the common factor, then we will get alpha minus k square into beta as the remainder. And now this minus alpha bar z as well as this plus k square beta bar z consists of the common factor minus z. So if we take out that minus z as the common factor, then we will get alpha bar minus k square into beta bar as the remainder. And then we have this plus alpha into alpha bar minus k square into beta bar is equal to 0. Now we are going to divide this whole equation by 1 minus k square. So if we divide this whole equation by 1 minus k square, then we will get z into z bar minus alpha minus k square beta divided by 1 minus k square into z bar minus alpha bar minus k square into beta bar divided by 1 minus k square into z plus alpha into alpha bar minus k square into beta bar divided by 1 minus k square is equal to 0. Now the coefficient of minus z bar here is